So, in some of my previous videos, I talked about designing 3D printing to make molds and other things to make materials better with printing multiple 3D materials at the same time. Here's an expansion of more precisely how I want to do it. And from the material aspects of actual materials we could use to do this. One is to print carbon nanomaterials to control the heating of it, or electrical conductivity. And we can add these carbon nanomaterials to inks that could be 3D printed if we want to make something super thin and mostly carbon nanomaterials, to resins. They can UV cure to plastics, to even metals. And carbon nanomaterials can have one of the highest thermal conductivities of any known material. So if we want to make a mold thermally conductive, so it can take in heat from a hot source and pump it into a place, it's great. If we want to let heat out, it's great. Or if we want to put in cooling stuff, it's great. It can also be electrically conductive if we want to put electricity through something to turn it into a magnet, or to heat it by making an alternating electric field that can cause an alternating magnetic field, or other more strange exotic thing that I might not be thinking of. Doping carbon nanomaterials with a little bit of boron can make them extremely more conductive for electricity. And they still already are very conductive on par with metals, but boron can push them past certain metals. Well, actually past most metals. Another thing is people can 3D print ceramics already for a variety of ways that I've talked about. And ceramics can be very good for electrical insulating, and they can not only be good for electrically insulating, they can also be very good for plastic insulating. So if we want to insulate and make like wires throughout the system, here we got the ceramic part for that. Or by mixing some ceramic and the conducting boron, like having a little bit of conducting, then some insulating and some conducting insulating, we can kind of average the two with how conductive and insulating it, more custom control. Also, I forgot to mention that carbon nanomaterials, besides being some of the most thermally conductive, they can be some of the most thermally insulating, the exact opposite, if they're made ultra light and not dense. So you can also use them for a good insulator if you want to keep in heat in certain parts, or have a part that's very hot and a part that's very cold. But it's also tricky because you have to worry about heat in any means moving from one part to another part, which might require active heating and cooling. Also, we can also add to some of these materials, and we already have 3D plastics printed, agents that foam under the right condition to make even more of a electrically insulating or thermal insulating, or expand some parts, or cause some parts to become less rigid, so when you pull the mold, it can expand and track with temperature more. Another thing that can be done is you can 3D print different metals together, or other materials together. And this is not the hard casting one, but it can be little plastic wires and stuff. And they can actually make a simple temperature sensor. Because if you have two metals or some of these other materials that are different, they actually, when at the interface, heat does not flow the best between the two different materials. Instead, electrons can flow more easily. So it carries on the heat energy. Electrons are transferred from one to another one. And if you make it sort of a diode, so that electrons are more transferred easily more in one direction, from negative to positive, and build up in the positive end, then you can cause a circuit that causes electric energy to be generated. And that is very small, but can be measured quite easily. Or there's ways to measure it by having stuff thermally expand and contract, causing different mixtures. And some materials become more resistive at higher temperature because stuff becomes more disordered. Foaming can help control how stuff thermally expands in the mold and contracts, and can also lead to spaces where stuff can expand in, or you can have very rigid specimens to do the opposite, to keep stuff rigid welds instead of expanding, contracting ways of giving. And if you make stuff with different foams and stuff and rigid parts, you can control thermal expansion quite precisely, mixing also different metals, different plastics and stuff in a non-rigid body. You can control thermal expansion much more than you normally would over wider temperature range without using really new materials. You could also print stuff with different solubilities in different liquids and use that to help extract the mold or dissolve some way to support the mold, so you have a mold that's more lightweight because you got rid of all the supports you made while printing it, or get rid of some more sensitive parts. So something else you could do is you can control the hardness of the material very precisely. And for example, it's not letting me fix that typo. Talc is one of the least hard materials, and graphite can also be not very hard. If you mix some of that into the thing you 3D print, you could have a lubricant almost that helps remove stuff more easily, or makes it less abrasive when you're pouring stuff in. Now, sometimes that's going to wear down, and you're going to have to put it in or make a new mold, but it's an idea. On the opposite, you might want to have something very hard to anti-wear it. You can print very hard carbon nanomaterials or metals or ceramics into the mix. Another idea is you could add antioxidants of a variety of types. And the nice thing about antioxidants is they can prevent oxidation of some metals as you're pouring it. You could have plus on some anti-stick stuff, so more easy to remove. Or you can actually have the stuff you print be anti-stick. You know, the problem with both of these is a lot of anti-stick compounds are toxic, are slightly toxic to highly toxic. So it's more of an industry setting thing. For example, fluorocarbons. You could print into something channels for heating and cooling stuff where you can pump in and out of liquids. Or for expansion channels. Could be another thing you could print in. Another one is you could have channels that act as filters or other things, such as they only let in, you pour in a liquid into it that's dirty, and surrounding it is a little plug that only lets the liquid in and filters off all the debris for making molds of certain materials. Or the liquid can not go through it, but gas can be let out or let in through tiny little pores that the surface area of the liquid stops it from penetrating there. And you can think about more complex ways of doing this and filtering. Or you could have it that you pour in one substance first, it can go through certain size channels, then you pour in another one that can go through other size channels into different parts of it. Along those lines, and maybe you can put a filter in with carbon nanomaterials or clay or something like that that filters out certain materials or gases as you're doing this whole thing. An even further idea is maybe you can make this whole thing in some way transparent, and maybe not necessarily transparent for light for the visible spectrum where we can see, but in some way transparent to like maybe infrared or other one, so you can more observe the whole thing, see if something's going wrong, to learn how to design better molds in very complex setups, or just for demonstration purposes to inspire future people. Well, thank you very much for listening. Please like and subscribe. It will help us 10 out. I'm trying to reach 1,000 subscribers on year and 4,000 watch hours, but it's really hard. With your help, I think can do it. Or see if any of these are future videos, comments, or suggestions. Please let me know and leave them in the comment section below. Again, thank you very much. Goodbye.